Aerodynamic forces. The four forces acting on the helicopter are identical to those for aircraft and include lift, weight, thrust, and drag. The lift is the force created by the effect of airflow as it passes around the airfoil. As we see in this figure, this is the lift. The second one, the weight. The weight is opposes lift and is caused by the downward pull of gravity. And this is the weight, and it opposes the lift and produced by the gravity. After that, number 3, thrust. The thrust is the force which propels the helicopter through the air, and it's produced by the engine. This is the thrust. The last one, the drag. And drag, which is retarding force created by movement of an object through the air, and it's opposed the thrust. Lift. The principles applied to the Venturi also utilized to create lift for a helicopter. However, rotor blades with an airfoil shape are used to create a pressure differential in the air. According to Bernoulli's principle, there is an acceleration or increase in the velocity of the air as it flows around the curvature of the airfoil causes the speed of the airflow to increase. This increase in speed over the rotor blade causes a decrease in pressure above the airfoil. This decrease in speed below the rotor blade causes an increase in pressure below the airfoil. The remaining lift is provided by blade's lower surface as air striking the underside is deflected downward. The span of rotor blade is the distance from the rotor hub to the blade tip. The twist of rotor blade refers to a changing chord line from the blade root to the blade tip. Also, the pitch angle is the angle between the blade chord line and a reference blade of rotation. A rotor's angle of attack is the angle between the rotor's chord and the relative wind. And the last thing, the disc loading of a helicopter, which is the ratio of weight to the total main rotor disc area. Control of lift. Lift is increased in two ways: by increasing rotor speed through the air or by increasing the angle of attack. A pilot can increase or decrease rotor speed and thereby increase or decrease lift. However, in most helicopter operations, rotor RPM is kept constant, and change in lift can be accomplished by changing the angle of attack with collective. Weight. Normally, weight is thought of as being a non-fixed value. That is the weight of the helicopter, fuel, and occupants. To lift the helicopter off the ground vertically, the rotor system must generate enough lift to overcome or offset the total weight of the helicopter and its occupants. This is accomplished by increasing the pitch angle of the main rotor blades. Drag. Drag is the force which opposes helicopter movement, as we said. The total drag acts parallel to the relative wind in a direction opposite the helicopter's movement. You learned earlier that there are two main types of drag: induced drag and parasite drag. The induced drag is created in the process of the rotor blades developing lift. Higher angle of attack, which produce more lift, also increase induced drag. As airspeed increases, induced drag decreases. It is the left major cause of drag at reduced airspeed. Thrust. Thrust, like lift, is generated by the rotation of main rotor system. In a helicopter, thrust can be forward, rearward, sideward, or vertical. Remember, the resultant of lift and thrust determines the direction of movement of the helicopter. The tail rotor also produces thrust. The amount of thrust is variable through the use of anti-torque pedals and is used to control the helicopter's movement around the vertical axis.